When a transformer's secondary winding is left open, meaning there's no load connected and no current can flow through it, the transformer's behavior changes significantly. The original question asks if under these conditions, the transformer acts like an inductor with characteristics corresponding to its primary winding. The answer is yes. Here's why an open secondary presents an infinite impedance to the secondary circuit, effectively preventing any current from flowing there. Consequently, the primary winding becomes the dominant factor in determining the transformer's electrical characteristics. Essentially, all the current flowing into the primary winding must circulate within that winding itself. This circulation of current within a coil is precisely what defines an inductor. The inductance of the primary winding, along with the frequency of the alternating current applied to it, determines the inductive reactance. Inductive reactance is the opposition to the flow of alternating current caused by an inductor. The voltage across the primary winding and the current flowing through it are directly related to this inductive reactance. They obey Ohm's law, modified for alternating current circuits, where voltage equals current times reactance. The inductance value is dictated by several factors, including the number of turns in the primary winding, the core material used in the transformer, the geometry of the core, and the spacing between the windings. All of these contribute to the primary winding's inductance and, therefore, to its behavior as an inductor when the secondary is open. The open secondary also means there's no voltage transformation occurring. Normally, a transformer changes voltage levels between the primary and secondary windings based on the turns ratio, the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. However, with no secondary current, this transformation ceases to exist. This behavior, where a transformer with an open secondary behaves as an inductor, isn't just a theoretical curiosity. It's intentionally used in some practical applications. For example, a transformer with an open secondary can be deliberately employed as a choke or inductor in electronic circuits. A choke is simply an inductor designed to block or impede alternating current while allowing direct current to pass. By using a transformer with an open secondary, one can achieve a specific inductance value needed for a circuit, utilizing the primary winding's inherent inductance. The inductance can be designed to the desired specification. The primary inductance and impedance are functions of the number of primary turns, the core material's permeability, and the core geometry.